Good morning and welcome to the value-added course on data analysis using Python. Today our discussion is on Pandas series. As you are well aware of the fact that this particular course is giving you two Python libraries, namely NumPy and Pandas. The previous class we have discussed about the NumPy libraries, which is an one-dimensional data structure. Today, we are going to discuss about Pandas series, which is also a one-dimensional data structure with heterogeneous data type. NumPy deals with the same data type, and the Pandas series deals with multiple data types. So coming to the agenda, we'll be introducing the Python libraries. We'll be discussing upon Pandas series, how to create a series, accessing elements of a series, attributes of a series, methods of a series, and some mathematical operation on the series. So Python library contain a collection of built-in modules that allow us to perform many actions without writing detailed program for it. Each library in Python contains a large number of modules that one can import and use it. And one such library is NumPy. And today our discussion is on Pandas. NumPy, Pandas, and Matplotlib are three well-established Python libraries for scientific and analytical use. These libraries allow us to manipulate, transform, and visualize data easily and efficiently. Pandas, the abbreviation, is derived from panel data. It is a high-level data manipulation tool used for analyzing data. It is very easy to import and export data using Pandas library, which has a very rich set of functions. It is built on a package like NumPy and Matplotlib, and gives us a single convenient place to do most of our analysis and visualization work. Pandas has three important data structures, namely series and data frame, and panel to make the process of analyzing data organized, effective, and efficient. Some of the differences between Pandas and NumPy are: NumPy array requires a homogeneous data, while a Pandas data frame can have different data types like float, int, string, date and time, etc. in one file. Pandas have a simpler interface for operations like file loading, plotting, selecting, joining, group by, which come very handy in a data processing application. Pandas data frames make it very easy to keep track of data, and Pandas is used when data is in the tabular format, whereas NumPy is used for numeric array-based manipulation. And coming to the installation procedure, installing Pandas is very simple. To install Pandas from the command line, we need to type in the command called pip install pandas. We installed the NumPy library using pip install NumPy. Similarly, a similar command is used here to install Pandas. Data structure in Pandas. A data structure is a collection of data values and operations that can be applied to that. It enables efficient storage, retrieval, and modification of data. Two commonly used data structure in Pandas are series and data frame. And the series is one-dimensional array containing a sequence of values of any data type, which by default has a numeric data. Label starting from 0, and the data label is associated with a particular value is called index, and also assign a value to other data types as index. So you can have index values by default from 0 to n number of values. It will assign an index value. We can access the element by using the index value. Now coming to creation of series. creation of a series from a scalar value. A series can be created using a scalar value as shown in the example below. For example, for any pandas related function, you will have to import pandas with the alias name PD. So with the NumPy, we are using alias name. Similarly, for pandas, you are using alias as PD. So import pandas with alias name PD. And for creating a series, pd.series is the command which is used. You are supplying a list here, and this list will be converted into a Pandas series in the name series 1. Now, if you print the series, it will be like this. So the content with the index name, index will be 0, 1, 2, and the values will be 10, 20, and 30. And the data type, by default, it is going to assign integer. Since all these are integer number, it default assigns a int 64 type. Similarly, we can have some more example of a Pandas series, pd.series with string. So you have Kavi, Sham, and Ravi, and so on. And you can specify our own index. By default, the index will be from 0 to n values. Here, the index we are going to specify for Kavi, it should be 3, for Sham, it should be 5, and for Ravi, it should be 1. So we are having the output as 3, 5, 1. 3, 5, 1, and so on. This another example involving index in the textual format. Here, pd.series contains the elements 2, 3, 4, but the index February, March, and April, and try to print this series. So index value February, value 2, index value March, it is value 3. And for April, it is going to be 4. So creation of series from NumPy arrays. To create a series of one-dimensional array, NumPy array, as shown below, we'll have to import NumPy as NP and import Pandas as PD, because these two are interrelated. So we are going to use both NumPy as well as Pandas. So NumPy array, from NumPy array, you can convert it. So you have already studied NumPy array. We can create the np.array, given a list that will be converted into array, where it is going to be an NumPy array. And this NumPy array can be converted into a series. So pd.series followed by, if you supply the NumPy, you are going to give the series. And we can print the series. You will have the values like this, 0, 1, 2, 3, and so on, with the output values assigned there. For index 0, value 1, similarly, all the other values. So creation of a series from dictionary. Similarly, we can also create a series from dictionary. So you have already learned a dictionary in the first unit. So using the dictionary also, we can create a series. So Python dictionary, as you know, has key and value pair. So set of contents with the key and a value pair. And the value can be quickly retrieved from its, if the key is known. So dictionary keys can be used to construct an index for a series. Hence, keys for the dictionary 1 becomes index for the series. So for example, here we have dictionary 1, which contains a value Indra, India, New Delhi, UK, London, Japan, Tokyo, and so on. And if you print the dictionary, it is going to, India is going to be the key, and value is going to be, the capital is value. And for UK, it is London. For Japan, it is Tokyo. So 3 sets of values are going to be displayed. So when you display the dictionary, you can convert the dictionary into a series using this pd.series command. Now you try to print this particular series. You have the key in one side and values on the other side. And it is, data type is going to be of object data type. Accessing the element of a series. There are 2 common ways of accessing the elements of a series: indexing and slicing. Indexing in a series is similar to that of NumPy arrays, and it is used to access the element in a series. Index are 2 types: positional index and label index. Positional index takes an integer value that correspond to its position in the series starting from 0. So you have the index position, you specify the position, you will get the value. So the labeled index, any user defined label can be used as an index. For example, if you want to have a Pandas series, you can create a series in the value series num, and you try to print one value. So we are giving a series number of index 2. So this is index 0, this is index 1, and this is index 2. So 30 is the value which is given as an output. So if you specify the index, the value can be fetched. So example for a labeled index. Similarly, you have a series pd.series followed by an list is specified, and the series dot numbers is available with index values February, March, and April. And now it's try to specify the index series month. If you specify March, the value related to March is going to be 3. So you are getting 3 as output. This is labeled index. Now coming to slicing. To extract a part of a series, this can be done through slicing, as we have discussed it in NumPy arrays. This is similar to slicing in NumPy arrays. To define which part of the series is to be sliced by specifying the start and end parameters, that is within square bracket, you can specify the start and the end with the series name. So when we use positional indices for slicing, the value at the end index position is excluded. So you give the start value and end value, end minus 1 location, you are going to get the output. The number of data values will be from the series are extracted with the end minus start values. So that many number of values will be available in the output. So, for example, we can have capital and country. We have Pandas series, that is New Delhi, Washington, DC, London, Paris as key value, and index as India, USA, France, and so on. Now, if you are going to specify 1:3 in the slicing, start from position 1 and go till 3 minus 1 location. So so position number 0 is New Delhi, position number 1 is Washington. So we are starting from Washington, and it is going up to 3. 3 minus 1 is 2. So this is 0, 1, and 2. So up to London. So start from location 1, end before the location 3. So that is the meaning of the 1:3 in this slicing parameter. So it excludes the value at index position end. So end position value will be excluded, and it will be using the position 1 before that location. Right. If the label indexes are used for slicing, then the value at the end of the index label is also included in the output. This is for only numeric slicing. So for labeled slicing, if you are going to give like this, so USA to France, so you will start from USA and end till France. In this example, so it is starting from USA, and the end index is also included only in the labeled indexes. And there are many attributes of series. You can assign name to a series. The example is given here. You can give a name for the series. You can assign name for index. So series capital country is the name of the series. Dot name, you can give some name. And similarly for index name, you can assign some index name to the index also. And similarly, value, you can print a list of values in the series. We can print the value, we can print the index also. If you are going to give values, only the value will be printed. If you want the index to be printed, you can also use a similar command for printing the index. Size attribute prints the number of value in the size object. In the previous case, there are total number of 4 entries. So the size is going to be 4. And there is another attribute called empty, which prints true if the series is empty and false if otherwise. If you want to check whether the series is empty or not, we can use the attribute name called empty. With this few words, I would like to welcome all of you for this value added course on Python. Thank you.